Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellyn, Illinois. And this video is part 3 of 3 of an object-oriented programming example problem/project using C++. So in the previous 2 examples, part 1, we went ahead and set up the boov class to set up how many health would the character need to survive 12 rounds of battle. And again, if you need to go back and watch those videos. If you're like, what is this? What are you even talking about, Brad? Boovs and gorgs and all sorts of stuff. Look at part 1 and part 2. But part 1 was setting up the boov. Part 1 was setting up the boov. Part 2 was setting up the gorg. And now part 3 is going to be what we call refactoring. And so when we're done with this part, our code is going to run. Let's say the results are going to come out exactly the same. It's going to be as if nothing ever happened to the end user. Refactoring is a disciplined technique, it really is disciplined, for restructuring an existing body of code, altering the internal structure without changing the external behavior. So again, this takes experience. This is probably your first time trying something like this. And it just takes a lot of experience over a lot of time to get it down. And even when you do, there's always room for improvement and so forth and so on. And it's generally a series of small changes. And each transformation is called a refactoring. So that's the end-all be-all to this thing. You can go to refactoring.com if you want to see what's going on with that. A lot more information than what we're going to cover right here, right now. There's an entire book on it that shows you 30 or 40 or 50 different ways to refactor your code. And it's an important thing because as you push forward in your projects, especially larger and larger projects, you're going to program yourself into corners. And so if you don't have the experience to see that, you're going to have to go back and fix everything up. And you're going to have to refactor, or else you're going to be spending more and more time to implement tinier and tinier changes to your code. But coming back to our problem here, remember, my way of doing things gets me a 54% boov victory rate and a 46% gorg victory rate. Some students have slight differences, and I know that's just because of the way the requirements were written in the previous parts. And seems like maybe I'm arbitrarily following certain rules when it comes to shields and health and things like that. But that's part of the fun of design work, is unless you have the designer right there and you can yell at him and ask him questions, there's no way to know exactly what the thought process is. Or maybe they didn't even think of it. Like there's a couple times I'm looking at this and go, oh my goodness, I didn't even think about the shield and the health going down below 0 and things like that. But anyway, so the refactoring of this is we're in the final simulation part here. We're going to use inheritance and polymorphism. So we haven't been touching any of that. We've been using encapsulation, we've been using data hiding, and just basically setting up object-oriented programming in that more simple manner. And now we're going to be moving over and using the more complex and the more powerful ways of using object-oriented programming. So we're going to think about everything common to boov and gorg. And we're going to, what I call bubble up. We're going to create a third class that kind of sits above. It's a base. We're going to call it a base class, right? So you should also have watched my previous videos before you start with this about when it comes to inheritance and polymorphism. This is a more specific example of that previous video. And so we're going to bubble up the common stuff from competitor or into competitor from the boov and gorg, and based on how common the code is, there's a different, like the functions themselves, that's one thing, and then the code that sits inside of those functions is another. And that's where we get the differences between normal member functions and virtual functions, as we will see in however long this video takes us to get through. So the competitor class is going to be the base class, the boov and the gorg are going to be the derived classes. So when it comes to members, I'm just going to say this fast now, and then we'll come back. This is kind of like the introductory of like, what are we going to do? And then we're going to do it in a couple minutes here. So when it comes to the member variables, the name and the health and the shield, and this time around when I changed everything up, I added a shield value. All 3 of those things are common to both boov and the gorg. So we should probably move those things up into the competitor base class. All those 3 member variables. And the gorg has a 4th one, but that's not common, so that doesn't get bubbled up, as you will see. And so that means that the name, the health, and the shield, those member variables, as we bubble them up, you will see that we totally remove them from the gorg and the boov. And so a lot of students end up putting this health and name and shield in multiple places in their code, and all it does is cause problems with the compiler at runtime and all sorts of stuff. And then this will also apply for the get functions as well, because we will see that the get functions, and that, for other functions too, the names of the functions are identical, their signatures are identical, their code is identical. So why should we duplicate efforts and have duplicate versions of these get functions? At least with what we have, at least with the code base we have now. So, and then for everything else, say that will be left up to you. This is, this is a video that comes out after the students have completed their work. So in this case, they have worked on this, and now this is like basically the tutorial on how to get, how to 100% this thing. So again, if the same function name is used in both gorg and boov, the function should bubble up to the base class as a normal member function. But if the bubbled function shares the signature, but differs in its functionality, that's where we start thinking about virtual functions and pure virtual functions and abstract classes and all those more complicated thoughts. So for starters, let's say that for starters, and it's the only function that does this, the gets attacked function is identical, right? It's a void gets attacked with no parameters. It's a virtual function because the name is shared, but obviously the behavior of the function is different, whether it's the gorg versus the boov. And the same goes for anything else that you would ever do. And so what about is defeated? And we'll say right now that is defeated is basically the same as those other get functions, the get name and get everything, because the signature is identical and the code is identical under the hood. And that should do it. Yep, that does it for part 3. So, or at least for the description of that. So I have my code set up here. So you can see I have the two .h files, the two header files, the gorg.h and the boov.h. They're sitting here. All I've done is created this new competitor.h file and just gave it a basic skeleton. And now I'm going to go ahead and start doing the bubbling up. And what's cool about this is, generally speaking, at least right now in our project, we have to do very little to the actual implementation. The CPP files, we actually have to do very little to. We'll have to do something with the constructors, but everything else should probably require me to, to do no touching whatsoever. Okay, so let's start our conversation as I was previously discussing with, well, let's find all the things, at least on the side of the function signatures, let's find all the commonalities and move them over into the boov class. So the gorg has no parameters as its constructor. It's a default if you want to think about it that way. And then the boov has 3 parameters. It is different. We'll leave it alone. We'll discuss this more in later time here in a couple minutes. But as for pretty much the next everything else, right? Get name, get health, get shield, is defeated, gets attacked, name, health, and shield, all the member variables. Well, this max shield is here and it doesn't exist here, so that does not bubble up as well because it's not common. But everything from here to here is common. So I can rip it out. Let me put it in. And now you notice, like, keep the publics and the privates and things like that. But you notice a lot of this goes away. And the same thing goes for here. This is all common, all of it. And at least for the moment, I'm saying I'm going to fix this up in a little bit here. And this string needs to come along because I need to pound include this. And I no longer need to. I guess I need to include it here for the boov, but I can get rid of it here for the gorg because that string is not part of this thing anymore. Let me just bring that down so it's more, so everything is on the level here so far. Okay, good. And now you see everything kind of has gone away. And what am I left with, right? Like I'm left with a constructor. And then as we discussed with the way inheritance and polymorphism, at least inheritance works, is I get all this stuff for free. I get all that for free just for moving it over and claiming it. And of course, it's not implemented yet. There's a lot of code movement that needs to go around, but we don't have to change any of the code, the actual code we've written. We just have to change where the code goes. And so the max shield is private and specific to the Gorg, not to the Boov, so that sticks around, but everything else moves over, which is very cool. And then they say we're at a level of, okay, just from the function signature standpoint, everybody's happy. And now let's say for just member functions. So let's go ahead for the moment here and go into the gorg.cpp here. No, don't worry about a lot of this stuff. We'll fix this stuff up. But this code, right, the get name, the get health, the get shield, the is defeated, we'll leave those, and we'll leave this gets attacked here for now. And then, okay, all of that, that can go into competitor.cpp, and I'll need to create that. And I will move this over so we all have, there you go, we're all happy there. And of course, since I'm doing this manually, I'll need to include competitor.h. I'll have to turn gorg colon into competitor colon. Okay. But none of the code, as we're describing, none of the code is being changed here. The constructor is going to stay, and this gets attacked function is going to stay for reasons that will become more obvious in a little bit of time here. So now on the side of the Boov, the same thing applies. All of the commonality stuff, the get name, the get health, the get shield, and the is defeated goes away because that is now part of its inheritance structure, because it will be in a second anyway. And so it's still screaming out all these little things here. Things are wrong, things are wrong, things are wrong. Everything is wrong. Because now the Gorg and the Boov know nothing. So name is not a non-static data member or base class of class org. So we're moving stuff around, but the one thing we haven't done is tell the compiler, tell C++ here, that the Gorg and the Boov are going to use the competitor class in any way. These are, right now, these are all three separate classes, completely separate from one another, and they know nothing of how they interact. So we have to fix that by making this and saying, oh, okay, we are going to derive from class competitor. And don't forget this public. Those of you coming from other languages, do not forget that keyword public. If you forget, you have private inheritance, and then you're going to just scratch your head and go crazy, especially if you're if you're using C# or Java or those kind of things. You're going to be like, what in the heck did I do wrong? You didn't necessarily do anything wrong. We've moved on from the time of having private, public, and protected inheritance. It's like, oh my goodness, you have to be an expert to understand what the heck is going on. I have to be an expert to spell the word competitor. There we go. And I need to include competitor.h. Okay, so that means that all of these, everything over here now, the get name, the get health, the get shield, now that is part of the deal. That is part of what comes along for free. And since I've defined them and I have an implementation and a header for them, all of these functions are now part of this as if they were 5 minutes ago or 10 minutes ago or whatever it was. These functions can be accessed as if they're mine inside of the Gorg and inside of the Boov. Okay, so we're getting closer here. And now you notice this gets attacked function. I kind of got away from that, and I said, okay, this thing is not defined, and it just comes down to the fact that we've looked at this, we talked about it, and we say the gets attacked function, the signatures are identical. The void with no parameters, but you can tell that the code inside of here is very, very different. And that's where the idea of a virtual function comes from, because at runtime we want to figure out, we're going to have the program at runtime figure out which version of the gets attacked function should get run, as opposed to compile time, because we don't know. If we have a vector of these base class pointers, there's no way the computer at compile time could figure out which combination of Boovs and Gorgs would be in a vector. And so in this case, I make it virtual. And that that frees up some stuff here. And then because this may it's one of those things. Is there a base behavior for this? And this comes down to like, the answer is yes or no. There's no right answer, no wrong answer. But the right answer is there's no base behavior between the two of these. This is completely different than that. And you could almost guarantee if you had different battle types, different object types, that they would have different gets attacked functions as well. So because of that, we should make it a pure virtual function, which means we do not define it in class competitor. We rely on whoever derives from us to implement that function. And that's part of why this starts going crazy here. And I go, well, okay, if I steal it from here, and now I come back to the .h files, and I say, okay, now, let me make this a little bigger now, because I think we're done with this over here on the competitor side for a moment. And we can say, okay, virtual void, but we're going to define it now, and we're going to override it. Okay, and the same goes for boov. I can just basically steal this guy and just put it in here. And always seems like, is that something on my monitor? Nope. What is that, a little dot or something? I don't know what that is, a little green something. And now this is saying that I'm going to override the base behavior for the gets attacked function, which is no behavior, because we're not defining it here because there's nothing common to anybody who's going to ever use this function. And so now this is perfectly legitimate. Whoops, what's going on here? Let me take a look at this. And so now the name, the health, and the shield, this is kind of all going haywire here. And that's because, what does it say here? It's inaccessible. And so again, there's a lot of little things going on here, and you just have to nail it out and just work on it 10, 15, 20 times, maybe 5 times, depending on who you are. It took me a long time, since in my undergrad we didn't learn object-oriented programming. It was just when I came back into computers years later that they taught us it was the new hottest thing. That's how old I am, right? So what happens is it doesn't know that I can use these things because these are private over here. And so I don't always believe in using the word protected, but I do today. And that cures all of this problem. And of course, the people are coming right now to do the lawn. So I'm going to have to take a break from you guys. But by making this protected, see how all this goes away? And that all of that went away, and then all that's left is the construction here of the object. And once the guys are done with the lawn across the way, to you won't notice it at all. But to me, I totally will. We'll see how to fix up the constructors, because that's the last step before we move on. Okay, so now it's time to finally fix up all of the constructors. As you can see, I mouse over any one of them and I go, it's a non-static data member or base class of class Gork, and that's because everything is sitting over here in class competitor, which we are deriving from, but because they're part of competitor class and not part of boov class, I can't directly construct that part of the object. And so basically, we kind of think this out. There's name, health, and shield, which is common to all 3 of these. So the constructor is more similar to the boov than anything else. I'm going to steal this, bring it over. Let me make it, having 3 things open at the same time just kind of ruins everything. But you do what you got to do. So now this is competitor. Excuse me. So these are the 3 parameters that are passed along into the constructor of competitor class. And I can basically borrow this constructor and go over to competitor.cpp and create this. And move this over a little bit, Now it should, there we go. Now it should work like it was supposed to before, because when the competitor class gets the parameters, it sets the variables inside of the competitor.h, its member variables. So everybody's happy on this end. And so this is still completely broken on over here with the Gorg and the boov, but the competitor class is now set up correctly. Its constructor sets up these 3 member variables in the constructor and doesn't need to have anything inside of here. And so one thing to note is, because of all of these reasons, and then some more that we don't need to discuss right now, the constructor and the destructor are never virtual. You can't derive for, whatever. Everything has to be a custom constructor and a custom destructor inside of even your derived classes and your base class. And for this reason, exactly this reason, because I can't just set them up. I can go down here and do them in here, but that's not right. That's not the professional right way to do things. And so just to fix things up over here, I don't have to change the constructors inside of here for Boov and Gorg, but I do have to change up how they're implemented. And so they say, so I'm indirectly going to set up the name, the health, and the shield by calling my base class. And then passing along the 3 parameters and calling it a day. Because now the Boov constructor is going to call up the chain to its parent's constructor, and then that is where all the, and passing the parameters along, so you're just kind of passing the information along, kind of like a game of telephone in a way, but never gets lost. The name gets put over to here, the health gets put over to here, and the shield gets put over to here. And so now that's how the Boov would be set up. And so now on the Gorg side, you see that there's 3 of these things here. It's George, 30, and 5. And we just do the same thing, but instead of passing along parameters and or whatever you want to think of, variables, they're hard-coded because that was just part of the rules. And then the max shield, because that's still part of the Gorg, occurs after you call the competitor constructor. And so that will cover everything we need to know to get everything working for our 6 files, our 3 classes. And then to finish everything up here, now we can go ahead and work on the main function and see where this goes and see what happens and just talk about all the things that can and can't go wrong when it comes to using pointers and non-pointers and virtual functions and non-virtual functions and those kind of things. Okay, so with all the changes, I have gone back into the main. I haven't changed anything inside of main, but you can see I've rerun my program, and I basically have right around 54% Boov and 46% Gorg, just like before. So our refactoring is truly complete when it comes to setting this up. We've restructured the code internally, but externally, no one would be the wiser, and we've made everything, more powerful using inheritance and polymorphism. We've future-proofed this thing much better than we ever have in the past, and so forth and so on. But coming back and now looking at this, you go, well, this is not a real-world example of how these things get used, the Boov and the Gorg. And so I have a whole video series for the gaming class, the gaming in C++ class, where we create a game engine. And inside of that game engine, you will see that we have a vector of base class pointers. And without that pointer, things don't go right. So if I try to set up competitor, and I'm going to need to include competitor.h here, and say now, because of this is a relationship, Gorg is a competitor, Boov is a competitor, I should be able to fit this in. But you notice this goes wrong. And let's see how long a single Boov can last. Where is that in the code? Hold on, where does that come from? Where does that come from? Interesting. Well, whatever. Interesting. Wow, I've never seen that. Oh, here. Oh, goodness. How interesting. It puts the comment in there. I've never seen that before. Okay, so anyway, coming back. So there's a huge difference between like pointers and regular, just normal, everyday variable objects. And this is where this goes wrong. Static versus dynamic typing and generation of code, or just figuring out virtual functions. And so this screams out, object of abstract type class competitor is not allowed because gets attacked is a pure virtual function. And because I'm not using a pointer or a memory address or reference of some kind, this is trying to figure out at compile time statically how to figure out what to work with when it comes to the competitor. And at compile time, and say at runtime, it doesn't know. It just knows it's a competitor. That's all it knows. At compile time, it's a competitor. It doesn't have a clue, even though it's screaming out, hey, I'm a Boov. Right here, it's like, I'm a competitor. And so competitor, where is my competitor.h class? Remember, this is pure virtual. That's all it knows at compile time, because there's no way it can truly know at compile time what object is sitting under the hood, because maybe we change that pointer later on. Because maybe we change it from a boov pointer to a gourd pointer or some other object type that we don't even have described just yet. So at compile time, all it knows is this. And since it's not implemented, it's abstract. And so that's not, it's not going to work for you. And the same goes for George. The gets attacked function is not implemented because competitor does not implement it. So your first rule would be like, or your first thing you think of, let's just implement it. Like, no, it defeats the whole purpose of pure virtual functions, because there's no consistent behavior amongst the two classes to warrant, or even if we added more classes to this to make it worthwhile. So what we can do, we're coming back here, is why don't we just make it pointer equals new gorg, and then, O equals new gorg, and competitor pointer George. And now that changes quite a bit, right? So now I can at least rebuild that. You see there's errors. We'll fix that up here. And now I say, oh, and now it says, oh, wait a minute. Oof. I just typed in the wrong stuff here, right? Okay, so O is a boov, and George is a new gorg. There we go. I can do it. I can do it. Okay, so now this will build, and you go, oh, okay. And now just down here, this is different types. But now you see this works through because by putting a pointer in, we tell the compiler at runtime is where we're going to figure out which version of all these virtual functions will be actually generated and executed. So it's no longer sitting here looking at this level. The virtual pointer table will take it and actually run this function for the boov and this function, of course, for the gorg. I don't have the file open, but that's okay. You get the point. And so by changing that, you change the syntax, right? The dots go away, and you use this little arrow indicator arrow here. That's just the syntax of it. But everything else should now go because I made everything a virtual function. And now we should be back to what we had a minute ago, where everything was working properly. And now I just got to let this thing run for a second or two so we can see it. And I better get very similar results. And I do 54%, 46%. And this is how things would go in the real world. You would have base class pointers pointing to derived class objects under the hood. And that's the whole reason why we have virtual functions. And so you have to have pointers and you have to have virtual functions. You have to, like I just showed, that you have to have a pointer on the competitor side. And then the other thing is if I get rid of the word virtual, then the same thing applies. It wouldn't work correctly. So it's a two-step process in C++ to make this thing work. I need a virtual function and I need a pointer, or else it's going to generate the function calls at compile time rather than runtime. So that pretty much covers everything in an example of setting up object-oriented programming using the big four ideas. Excuse me. Data hiding, encapsulation, inheritance, polymorphism / virtual functions, and abstract classes and abstract functions and pure virtual functions and all that stuff. You know, this is kind of the tip of the iceberg. The next step is to master setting up inheritance and polymorphism, and then you move on into architecture and design patterns and those kind of topics where now, you know, things are a little more advanced, and we can, you know, and you will see that again if you ever take my C++ for gaming course, or if you watch the videos, you will see there are, you know, singleton patterns and state patterns and strategy patterns and visitor patterns and all these other patterns that we can use to set everything up. And the whole reason for this is to make our lives easier. Maybe it's a little tricky the first couple times we set these things up. You know, maybe this was tricky. It was definitely tricky the first couple times I went through this, you know, after when I was learning this stuff way back in the day, and it maybe is for you too. But once you get used to it, like anything else, you wonder how you never understood it the first couple times through. But anyway, swardb@cod.edu is my email address. Please get a hold of me there if you have any questions, or if I said something wrong in the video, or if something is wrong in the video. It's something like this is a little more advanced topic, so I can accidentally say or do the wrong thing. So, or if you just have questions about future videos or previous videos or anything like that, get a hold of me there or send a comment here on YouTube. So let's see. Next up, on, at least for my classwork, if you're a student, the next videos will cover templating of functions, exception handling, and then we're going to take a look at the vector class. We're going to take a look at everything there is to know about the standard template library and using a vector class, because in previous classes maybe you set one up and maybe you got it going and treated it like a smart array, but I guarantee you haven't used it to the level in which the standard template library allows you to use it. So that's the next video, and I'm excited for you guys to take a look at that. So have a great day, have a great week, wherever you're at, have a great weekend, maybe just whatever you're having, and we'll see you next time. Thanks, everybody.